All right, now that we've looked at calculating the probability for simple events using each of those three interpretations of probability theory, let's look at solving problems that involve complex probabilities by identifying the structure of the problem, isolating the simple probabilities, calculating the probabilities for those simple events, and then calculating the probability for the complex event based on the probabilities for the simple events. So let's start with this problem. Given an urn with 3 red, 2 yellow, and 4 blue balls, calculate the probability of drawing a blue or a yellow ball on a single draw. So I just draw my urns out, put in 3 red, 2 yellow, 4 blue. That way I have that information right there next to me. Now, I'm going to have one draw. And one favorable outcome for that draw would be I drew a blue ball. Or I have that draw, and a favorable outcome for that draw would be that I draw a yellow ball. So I have two different ways of having a favorable outcome. I could get a blue or I could get a yellow. So I know that I'm going to be using the disjunction rule. The next thing that I want to do is calculate out the probabilities for those simple events. So the probability for getting a blue ball is best determined using the classical theory of probability. I've got 9 possible balls, so my N is 9. I've got 4 blue balls, so my F is 4. I know the principle of indifference holds because I'm just as likely to draw one ball as any other ball. What about my yellows? Well, I've got 2 yellow balls and 9 total balls. So that gives me 2 over 9 for the probability of drawing a yellow. Since I'm going to use the disjunction rule, I have to ask myself, are the 2 ways of getting a favorable outcome exclusive? That is, one happens or the other happens, but they can't both happen. So if it's exclusive, I can use the restrictive disjunction rule. So I look at this and I say, well, I've only got one draw. If I get a blue, then I didn't get a yellow. If I got a yellow, then I didn't get a blue. So the 2 ways of getting an outcome that is favorable are exclusive. They can't both happen. So I can use that restricted disjunction rule. Now, restricted disjunction rule tells me that the probability of getting a blue ball or a yellow ball is going to equal the probability of getting a blue ball plus the probability of getting a yellow ball. So now I just have to plug my numbers into that equation like so, and I get 4 over 9 plus 2 over 9 equals 6 over 9, which I can simplify to 2 over 3. Let's look at a second problem. Suppose I've got 2 urns, one with 3 red, 2 yellow, and 4 blue balls, and one with 2 pink, 5 gray, and 2 orange balls. And now I'm asked to calculate the probability of drawing a blue or an orange with a single draw from each urn. So again, I draw my urns out, 3 red, 2 yellow, 4 blue, 2 pink, 5 gray, 2 orange. I'm going to have a draw from each urn. My draw for the first urn, to get a favorable outcome, I would have to draw a blue. My draw from the second urn, to get a favorable outcome, I would have to draw an orange. So if I draw blue or I draw an orange, I get a favorable outcome. So now I've got to ask myself, okay, I think I'm going to use the disjunction rule. I'll calculate the probabilities for the individual events. The probability of drawing a blue is 4 blue balls divided by 9 total balls. Now I go to the probability of drawing an orange. That is 2 orange balls divided by 9 balls total. Now I ask myself, are these events exclusive? That is, if I draw blue, does that mean I can't draw an orange? And if I draw an orange, does that mean I can't draw a blue? When I think about the different possibilities, I can think of 3 ways to get a favorable outcome here. I could draw blue, but not draw an orange. I could draw an orange, but not draw a blue. Or I could draw a blue and an orange. So these 2 events aren't exclusive. And that means I'm going to have to use the general disjunction rule. So the general disjunction rule tells me that the probability of drawing a blue or probability of drawing a blue or an orange will equal the probability of drawing a blue plus the probability of drawing an orange minus the probability of drawing both a blue and an orange. So again, I just plug my numbers in here. 4/9, probability of drawing a blue, 2/9, the probability of drawing an orange, minus 4/9 times 2/9, the probability of drawing a blue and an orange. And that'll give me 6/9 minus 8/81. To subtract fractions, I have to have the same denominator. So I'll multiply that first number by 9, and I get 54/81 minus 8/81, and that gives me 46/81 as the probability for drawing a blue or an orange or both.